Welcome to Mission Control. I am your flight director for today's explainer simulation, and we are initiating a highly requested critical launch sequence. We are cracking open the official examiner's blueprint for Cambridge AS and A-level mathematics, specifically locking our targeting coordinates on section 6.5, hypothesis tests for binomial, Poisson, and normal means. If you are prepping for this exam, you already know exactly how daunting these probability distributions can feel when the clock is ticking down and the pressure is critical. But today, we are stripping away the anxiety. We are treating this syllabus like a critical flight launch protocol that requires absolutely zero margin for error. We are going to look at the exact telemetry, the precise mechanics of what the examiners are scanning your paper for when they grade your responses. We are bypassing the standard textbook flight manuals entirely and looking directly at the raw assessment framework. Strap in, check your vital systems, and let's get this explainer off the ground. Okay, let's dive into this. I need you to look at the central viewing monitor right now. A senior Cambridge examiner recently issued what we consider a stark, system-level threat warning. Most students lose easy marks, but after this, you won't be one of them. This establishes the incredibly high stakes of our flight path today. Hypothesis testing isn't just about crunching raw numbers in the dark, it's about avoiding those simple, devastating atmospheric burnups that happen when you don't structure your answer exactly the way the marking scheme demands. You can have the most powerful engines in the world, but if your trajectory is off by a single degree, you lose the easy marks. I'm going to show you how to lock in every single point by thinking exactly like the flight engineer grading your paper. To get us to that A-star apex, here is our targeted flight roadmap for today's explainer. Stage 1. We will unpack the core theoretical principles that serve as the fuel for hypothesis testing. Stage 2, we lock in the procedural framework, the actual step-by-step navigation method you need to deploy under exam pressure. Stage 3, we fire the boosters into critical evaluation, which is exactly how you break gravity and access the top-tier marking bands. And finally, Stage 4, we will review the top 3 candidate mistakes, the fatal anomalies highlighted in principal examiner reports, so you can maneuver around them entirely. The countdown is active. Let's initiate Stage 1. We are clearing the tower and moving into Section 1, Core Theoretical Principles. Before you write down a single equation, before you even touch your calculator, you have to understand the fundamental assessment objectives, or AOs, that the examiners are demanding in Section 6.5. This is your target orbit profile. Cambridge scales their expectations systematically. They start at standard recall data points, basic definitions, simple formulas, and they scale all the way up to elite evaluation metrics. If you don't calibrate your launch track to match these exact AOs, you are flying blind. The assessment framework demands a fundamental shift in how you operate. You have to move away from superficial breadth and dive deep into analytical depths. Look at the telemetry on the screen. We are comparing a low-altitude descriptive trajectory with a high-propulsion evaluative pathway. You literally cannot just memorize formulas and expect to clear orbit. The examiners want to see that you understand the precise definitions, the causal relationships, and exactly why a specific test is being engineered for a given scenario. If the command word says assess, and you simply calculate, you trigger an immediate system failure alert on the examiner's dashboard. A calculation is just raw data. An assessment is telling command exactly what that data means for the safety of the mission. You must match the command word constraint perfectly. When we map out our 3 primary test engines, binomial, Poisson, and normal means, you absolutely must know their basic atmospheric applications. You need to know when discrete data demands a Poisson approach versus a binomial one. But here is the real secret to maximizing your propulsion meter. Principal examiner reports clearly state that candidates who utilize cross-topic connections, meaning they bridge their knowledge of hypothesis testing with other mathematical syllabus areas like continuous random variables or probability density functions, achieve significantly higher marks. It's about showing a cohesive, unified understanding of the entire mathematical system, not just firing isolated thrusters. When you link topics, your mark yield skyrockets. That brings us to Stage 2, the procedural framework. Theoretical knowledge is a great fuel source, but how do we translate that into practical, systematic execution during a high-pressure exam? To show you this, I'm patching you into a live simulation run with 2 of our top cadets. On comms, we have Pilot 1, Alex. Alex is a brilliant propulsion engineer, but his tendency is to overload the system with raw fuel logs. He just dumps facts and definitions onto the page, but burns way too much energy and constantly runs out of time. On the other channel is Pilot 2, Sam. Sam is a navigation specialist. She steers the flight layout incredibly fast, getting straight to the numbers, but she often ignores structural boundary coordinates and completely misses command word constraints. Let's listen to how they handle a live paper. The central debate between Alex and Sam always comes down to the method mark strategy. This is your conceptual anchor. In Cambridge exams, marks are heavily weighted toward the process. Alex is shouting over the comms, let's just write down every textbook definition of a type 1 and type 2 error before we even look at the numbers. We need to show we know the theory. But Sam is fighting the yoke, arguing back, Alex, we have 12 minutes left. Just skip the setup, slam the data into the calculator, give them the p-value, and let's get out of here. They are both wrong, and their propulsion meter is stalling. The method mark strategy dictates that marks are awarded for demonstrating systematic analysis. Even if Sam's final calculation is slightly off because of a slip digit, a perfect step-by-step methodology secures the majority of the points. You don't need an essay, Alex, and you can't just drop a naked number, Sam. You need systematic proof of your logic string. I'm stepping in to coordinate their telemetry. Here is the exact 5-step chronological journey we force our pilots to use for tackling any hypothesis testing question. Step 1. Deconstruct the question completely. Scan the structural data parameters. Step 2. Extract the relevant data from the noise. Step 3. Select your analytical framework. Is this a binomial, Poisson, or normal distribution engine? Step 4. Execute with crystal clear mathematical notation. And Step 5. Present your findings using correct, formal terminology. Once Alex and Sam align on this exact sequence, their debate ends. They stop wasting time on useless definitions, they stop rushing to unproven calculations, and they build a professional academic response that the examiners have to reward. Launch trajectory hold. Flight director override initiated. Right before we fire the secondary boosters to secure this top-band paragraph structure and clear orbit, we need to optimize your educational flight deck. Take a second right now to subscribe to Ace the Exams at Ace the Exams and enable all notifications so you never miss our weekly flight-tested exam hacks. Whether you are launching at IGCSE, O-levels, or AS and A-levels, we are your permanent mission control. Okay, the notification bell is active. Let's resume the countdown and shift our focus to Section 3, Mastering Critical Evaluation. This is how we ascend into the elite marking bands. Warning on the console. We are encountering an unexpected structural data loss mid-paragraph. Alex and Sam have successfully defined their null hypothesis. They've calculated the test statistic perfectly, but right as they are about to state their final conclusion, their evidence links completely drop. They are reverting to a descriptive trajectory. They are just about to write, therefore, reject the null hypothesis and move on. If they do that, mission terminates. They will lose every single evaluation mark. I am overriding the console and deploying a structural power-up framework right now to stabilize their text flow live. We are shifting them to an evaluative pathway by deploying the Peel structure. Point, evidence, evaluation, link. Listen to how we rewrite this response out loud, line by line, using this problem-solving cycle. First, deconstruct and solve. The calculated test statistic of 1.96 exceeds the critical value of 1.645 at the 5% significance level. That is the point and evidence. Now, check reasonableness and evaluate. This indicates that the probability of observing such an extreme result by chance alone is less than 5%, assuming the null hypothesis is true. Finally, make justified recommendations, linking back to the context. Therefore, there is sufficient evidence to reject the null hypothesis, concluding that the new factory machine has indeed increased the mean production rate of components. Do you see the difference? We didn't just drop a number. We engineered a perfectly balanced, high-scoring block of text that proves robust, critical thinking. The system is stabilized. We are approaching the upper atmosphere, entering Stage 4, the top 3 candidate mistakes. Now I am handing the console controls directly over to you. We've pulled these critical anomalies straight from the Cambridge Principal Examiner reports, and we are going to run a live radar check challenge. I need you engaged. Look at your screen. Challenge 1, the visual radar sweep. I am projecting a flawed medium-tier sample student response paragraph. Your job is to identify the logic malfunction before the 60-second timer runs out. Where's the structural precision dropping the score? Look at the 3 main pitfalls. First, answers that are too vague. Second, formatting errors. Third, responses not specific to the context. I'm triggering the digital indicator to highlight the discrepancy right now. Look at the final sentence. The student wrote, "The result is significant, so we reject H0." Bam! Complete logic malfunction. The response is completely detached from the given context. If the question is about a factory producing defective microchips, your conclusion must relate back to the microchips. You have to tether your mathematical logic directly to the real-world problem. Let's run Challenge 2. There is a massive examiner alert flashing on our telemetry right now. Examiners consistently report that candidates confuse key terminology, especially confusing a type 1 error with a type 2 error or misstating the significance level. Look at the radar sweep. The student jumped straight into calculating the probability of a type 1 error without defining what it actually represents in the context of the question. The golden rule of this launch sequence is absolute clarity. You must engineer an undeniable baseline. Always define your terms, your null hypothesis, your alternative hypothesis, and the practical meaning of your errors before you start calculating. Establish the laws of physics for your specific test clearly on the page before you hit the ignition. Telemetry is green. Alex and Sam have successfully completed the full mark launch sequence. Their propulsion meters have peaked at a maximum A-star reading. Mission success. Let me distill this entire session down into 3 universal rules for your next exam. Rule 1. The 3-step question scan. Decode the command words and establish your boundary coordinates before writing. Rule 2. The fuel budget allocation. Time is your fuel. Do not waste it over-explaining definitions when the question only demands a calculation, and do not rush the calculation when it demands an evaluation. Rule 3. The post-launch system review. Always check your final answer against the real-world context of the question. So the ultimate question is, next time you sit down with a past paper, will you just calculate the numbers, or will you engineer an undeniable evidence-based conclusion? If you are ready to conquer your next syllabus, subscribe to Ace the Exams. At Ace the Exams, click that notification bell for our weekly grade masterclasses, and drop a comment below sharing exactly which Cambridge subject and level, IGCSE, O, AS, or A-level, you are preparing to launch next. I am your flight director signing off. I'll see you in the next explainer.